Hello there, welcome to chemistry. I'm sure you've got lots of questions about A-level chemistry, and I hope that I'll manage to answer some of them in the next few minutes. Students have got lots of reasons for considering A-level chemistry. You might have enjoyed the subject at GCSE and you might want to take it further, possibly even study it at degree level. You might need chemistry for your future studies. Some courses like medicine require chemistry, and there are other courses like biology and some psychology courses who recommend it. This does depend a bit on the individual university, but it is something to consider. You also might just want to complement your other A-level choices with a science subject or an extra science. Now, all of these can be really good reasons for studying the subject, but what I want to say is make sure you are ready for the challenge and that you really want to do the course. Don't pick it just because you like exploding things and setting things on fire, fun though that is. Now, to help you make your decision, I'm going to talk about chemistry generally, and then I'm going to focus on the course here at Bootham and explain why you might want to study chemistry here in particular. Okay, so first of all, why chemistry? Well, chemistry is an incredibly important science. It's asking questions about the nature of matter, how materials behave, and lots of really fundamental ideas in terms of understanding the world. Chemists help develop new medicines and materials. They help design batteries that will power our electronic devices. We develop catalysts that will help improve the speed of chemical reactions and help reduce the environmental impact of the things that we're doing. Chemists inadvertently helped create the hole in the ozone layer, but it was also chemists who spotted the problem and who helped come up with creative solutions to try and replace the CFCs that caused it. Chemists are also people who ask lots of questions, and I want to just talk about some of those questions at the moment and see if these are things that you find interesting yourselves. How do chemists identify elements on distant stars or in the laboratory? We'll be looking at these particular diagrams here and thinking about how they provide evidence for elements that we can only see in outer space. How can a steel paperclip float on water? What are the forces in the water that allow that to happen? And why, if you drop a little bit of detergent in there, does the paperclip sink to the bottom? Why is water such a good solvent? It's incredibly good at dissolving things, and that has lots of impact in terms of how the world works. How do chemists tailor-make the best fuels? Why is glue sticky? What is it about the forces within the glue that allow it to stick to some materials but not others? Here's one we've talked about already. How is ozone destroyed? Part of the A-level course, you're going to have a look at the ozone layer and some of the chemistry of the ozone layer and how it got destroyed and how chemists have worked to try and fix it. As part of the A-level course, we look at things like how smog is caused, incredibly polluting effect. How is it caused and how can we fix it? You'll learn how to design a drug molecule. So how do we make medicines? How do we design them to work better than they did before? We'll look at how we can make hydrogen power viable, how we can get electricity from burning hydrogen. We'll be looking at molecules that make materials bulletproof. As part of our A-level course, we also look at things like ocean chemistry. We look at dyes and materials, how we can get the colours right in fabrics. And we look the chemistry of life, and we look at things like DNA and natural polymers that allow us to understand what's going on in the human body. We'll also look at how everything, just about, can be explained by looking at probability. And we'll think about an idea called entropy that allows us to actually understand that a bit better. Now, if you're interested by some of these questions and you want to know the answers in a lot more detail, you might just want to study chemistry next year. Okay, why would you want to do that though, particularly at Bootham? Well, first of all, we have a really strong tradition of science at Bootham. Chemistry department is no exception to this. We have a long history of getting very good results from our students and very good value-added results from our students as well. We're very lucky to have experienced teaching staff, small teaching groups, and large, well-equipped labs to work in, with fantastic technician support. The A-level course has a very strong practical focus, and we're managing to keep going with this in spite of the COVID restrictions. Our students are often able to carry out practical tasks individually, even with quite equipment-heavy practicals like distillation and reflux. We have plenty of equipment that allows students and space to allow students to spread out and get that done. This is really helping to build practical skills, and our students come out of the course with a really strong experience in practical chemistry. The course we do at Bootham is another thing to consider. We do the Salters, which is the OCR B A-level chemistry. Now, most chemistry A-levels teach A-level chemistry as a topic-based subject. So you might do a topic on rates, you might do a topic on organic chemistry, and everything is very much put in little boxes. And that's similar probably to what you've done at GCSE. So the Salters course is quite different to other A-level courses that you might have met. Although we cover much of the same content as other chemistry A-levels and you come out with the same qualification at the end, the Salters course deals with the ideas in a context. For example, we might look at something like what's in a medicine, developing fuels, the ozone story, or the oceans. And then we deal with the ideas that you need in order to understand what's going on. For example, as part of the developing fuels topic, we look at the energetics of fuels. And we also look at some of the organic chemistry we need to understand hydrocarbon fuels and how they work. In the oceans topic, we look at solubility, because that's quite important. The oceans have a lot of stuff dissolved in them. We also look at the maths behind pH, and we look at some of the complex processes that affect the acidity and the temperatures of the oceans. And we think about how these influence global warming and how they're affected by them. So very relevant and topical ideas that we cover there. The course covers much the same content as other chemistry A-levels, just in a slightly different order. We find that students come out with an excellent knowledge of chemistry, but also a really good understanding of some of the chemistry we see in everyday life. We also find that the course is very well designed. It helps students really understand the concepts because we keep revisiting certain key ideas as we go, and we find that this really helps reinforce your learning and deepen your understanding. It's also really interesting, and students get very interested in some parts of the courses that sometimes can appear quite dry in other A-levels. Right, okay. So what do you need to succeed at A-level chemistry? If you're starting to think that this really might be for you, what are the things that are going to influence whether you can succeed or not? First of all, and probably the most important thing, we'd really like you to have an interest in chemistry and a love of asking questions about the material world around you. Interest and enthusiasm go a long way to helping you stay motivated when things get hard. The second thing we're looking for is for you to have a really solid understanding of the GCSE chemistry course. The A-level course builds on GCSE ideas, and so you need to be really confident on the GCSE content, which is why we would recommend a grade 7 or above for most people when we're doing this. We're also looking for you to have a willingness to work hard. No one, whatever grade you come out with at GCSE, can coast a chemistry A-level. Even those who do very well need to be prepared to put in the time and effort to succeed. The A-level is a significant jump up and you need to be prepared for that. So you need to be willing to work hard. That's also really important. We'd also recommend that you're someone who has strong math skills. 20% of the A-level chemistry marks are for mathematical skills. So you need to get really quick and accurate in your maths. We want you to be confident in maths and happy carrying out different types of calculations. Things like moles calculations that you'll be doing at GCSE, but also things like converting units, working in standard form, and also rearranging equations with confidence. You'll also need good English language skills, and if English isn't your first language, you'll need to be willing to work at that really quite hard to build your vocabulary and build your fluency in writing in English. You need to be able to read and interpret questions, use complex chemical vocabulary, and you need to be incredibly precise in your use of language in chemistry so that you're using each term correctly. Now, that sounds like quite a lot, I'm sure, but our students often tell us that chemistry is the hardest A-level that they do. They also tell us, invariably at the end of the course, that they're glad that they've done it. Just about every student who comes out says, I'm glad I did that, because they learn so much from it that they can transfer to other areas of learning. Chemistry is not an A-level to take on lightly, but it's a fantastic course to do if you've got an interest in the subject, if you're willing to work hard and to challenge yourself. And there's still the odd chance of the odd explosion or fireball just to keep things interesting. I hope that I've answered most of your questions about the course, and I look forward to seeing some of you in person in chemistry lessons next year. Do get in touch if there's anything else that you need to know. Thank you.